the resistance of a piece of a wire of length, 20 meters, and a cross-sectional area, 8 times 10 to the power minus 6 meters squared, is dash. That's you that what is the resistance of this wire now, right? So the resistivity of the wire is given as this. So, first of all, we don't know the formula yet. Let's bring out the parameters from the question, right? So from the question, we have that the length of the wire is given as 20 meters, right? And then we have the area of the wire is given as 8 times 10 raised to the power minus 6 meters squared. And then we have resistivity. The resistivity is given as 4 times 10 raised to the power minus 7 meters. Now when you have this, we are talking about the resistance of the wire. What is the resistance of the wire? When its cross-sectional area is this and the length is this. There's a relationship between the resistance of the wire and the length of that wire and its cross-sectional area. So the relationship is given as this. R equals to the resistivity times the length of that wire divided by its cross-sectional area. So what we need to do here is to come here quickly and substitute the value of resistivity, which is 4 times 10 raised to the power minus 7 times the length of the wire, which is 20 meters. We don't need to convert anything because we have meters, so no need to convert to any unit. So you now divide all these by the area, which is 8 times 10 raised to the power minus 6. Now looking at this guy here carefully, you have 4 times this to power this. So let's use the power first. Not to have issues because we have a multiplication sign, two multiplication sign. It means that everything is multiplied in the numerator. So we have, take this 4 times 20. 4 times 20, right? That is 20 in 4 places. 20 is 40, 20 is 40, 40 plus 40 is 80. So you have 80 times 10 raised to the power minus 7 divided by 8 times 10 raised to the power minus 6. Now, look at the denominator. This is a jump question, so we are trying to avoid wasting our time to calculate. So look at to use calculator. So look at this denominator. You have 8 times 10 raised to the power minus 6, and here you have 80. So there's a possibility of making this power look the same as this, and this are the same thing as this. So since you have 80 here, we consider the decimal point being outside. So if we move the decimal point from outside inside here, right, that is one place. That means that we are taking the power to be plus 1. When you move from here inside, the power is positive. But when you move from here backwards, the power will be called negative. That is the primary school mathematics. So now, since we move from here inside, we'll be having something like 8 times 10 raised to the power 6 minus 7 plus 1. Like if you have a negative and a positive sign, it's as simple as telling you that you are owing, minus meaning you are owing something. You are owing somebody 7 oranges, and then somebody dashed you 1 orange. You rush to go and pay the person you are owing, you pay your debt. How many oranges are you still owing? You are still owing what? 6 oranges. So the owing is accepting as negative 6. Then you divide all these by 8 times 10 raised to the power minus 6. So you can see that both there is 8 here, 8 minus 10 to the power minus 6, 10 to the power minus 6. So everything will cancel out, this will give you 1. So therefore, the resistance of the wire will be 1 ohm. That's it.